Let's go fast. Okay. Here are some definitions. A bisector, a line that divides a line segment into two lengths. Perpendicular bisector. It makes a 90-degree angle with a line segment. Okay. The median of a triangle is a line segment that joins a vertex, so one of the points of your triangle, to the midpoint of the opposite line segment. Okay, so something like this. I'll draw you a little picture. Okay. The median goes from a vertice to the, did we say the midpoint? Yeah. Okay. The red line is the median, because we're roughly getting to the midpoint of the opposite side length. Okay, that's a median. The altitude is the line segment that passes through a vertex and is perpendicular to the opposite side. Okay, so that one looks like this. This is not necessarily the midpoint. It does meet at a 90-degree. These two things are different. Okay, one meets at a 90-degree, the other one just goes straight to the midpoint. Two different. They can be at a bit of an angle. You see how this one on the left is a little bit at an angle? Yeah, Retta.
Isn't that more of a perpendicular bisector?
Yeah, I think you could kind of. The altitude is like how tall the triangle is. That's what we were having a conversation around yesterday.
Yeah, I know. I figured that a bit.
Right? It's the height of your triangle. I suppose you might use that on your assignment, but that might be the end of it.
Is that how you draw an altitude, or is that how you draw a perpendicular bisector?
I'm just thinking they're kind of the same thing in the context of a vertice to the mid, like perpendicular, but I'm trying to think of another instance of maybe like a perpendicular bisector could be something like this too, right? I don't know if it necessarily has to go through a vertex. Retta?
Is that what it is? Like, how's that perpendicular bisector if it's not a 90 degree?
It intersects the side length at a 90-degree angle. I don't think it necessarily has to go through the vertice, is maybe the differentiation there.
Is it?
I think the altitude of the triangle has to go through the vertex, but a perpendicular bisector, I don't think has to. Like there has to be differentiation between the two somehow. You know what I mean?
There should be.
There should be. I think that's the differentiation,
I'll look into it.
is whether or not it goes through a vertex. You look into it, you let me know. Okay? Okay, so we got an example. Let's plot. This is good experience for you guys, I think, too, like with what you're working on right now. Triangle ABC has vertices A, B, C, and they're the points. Let's go plot them. That should be your first step always. Okay, just go plot them and see what kind of triangle you're dealing with. Okay, so A is at 8 and -6. B is at -6, -8. Okay. And C is at -4, 6. Okay, here's your triangle. So we can draw that. Ah. Okay, any issues? All we've done is plot points, so I guess you could label them A, B, and C. Okay? So there you go. Let's do the next part. If the median from A intersects BC at a point called D, what's a median? It's just a line going from the vertex to the side length. Okay? Determine the coordinates of D. Okay, we don't necessarily know where D is. We're just going to draw it on there. I'll do that in green, okay? Okay, trying to figure out what the coordinates of D are. And then the median is just from A to D.
Why did you draw it?
Huh?
Why did you draw it already if you don't know the exact value?
We just need something to solve for visually. We're just drawing visually. Just so like we can look at that picture and understand when we go back, we're like, I just found a point. Well, I don't know what it means. It's on the picture at least. Okay? So, what are we going to need? Yes, Retta, sorry.
The midpoint of BC.
The midpoint of BC? Is it necessarily going through the midpoint?
Yeah. Okay, well, it says median triangle line segment that joins the vertex.
I know. Just running through the process of what everybody's thinking in their heads. So yes, let's go look at the median. It says it goes through the midpoint. Okay, which is where I chose to yeah, you better fix that before it falls out. Can you reach the handle or no? Yeah. Without falling out the window, obviously. Okay. Let's find the midpoint of BC. Midpoint of line segment BC is equal to x2 plus x1 divided by 2, y2 plus y1 divided by 2. That's a coordinal point, right? So you just use the points, BC. These are the two we're using. Plug in the x values, divide by 2. Plug in the y values, divide by 2, okay? That's the midpoint. That's the coordinates of D. D is the midpoint of BC because it's a median. Okay? So x2 we're going to say is negative 4 plus negative 6 divided by 2. And y2 is going to be 6 plus negative 8. Yes?
Could you also write MXY of line BC? That's
Oh, what we had wrote yesterday, yeah.
MXY of line.
Yeah, the problem is like even like because I'm looking at the solution here, I've written this. Which threw me off for a sec, because I'm like, I'm finding the slope? What's that gonna do for me? You know what I mean? You guys just be careful with what you denote what, right? Because you don't want to confuse yourself. Right? So if what Red is saying is this is okay, you guys can, I would use capital M and make sure it's a clear capital M for midpoint, right? X, Y. That's fine.
But then would you also write line BC?
I'm not too,
Because wouldn't you need to like identify which line?
yeah, probably actually, yeah. For your own purpose, yeah. Yeah. For your own organization, you're probably going to want to keep it as specific as you possibly can, right? So that it's, especially for your assignment, because that piece of paper is going to have about 15 calculations on it. Okay, so be specific.
I mean, to be fair, it is one question that's worth like 22 or 23 points.
And you're having 5 days to work on it, 6 days. Okay, so we get, sorry, what was I doing? You guys distracted me again. These are the coordinates of points D. Any questions? All we've done there is taken the idea of what a median is and applied it to what we already did yesterday with finding the midpoint. If I asked you how long is that median, you can now plot those 2 points into your distance equation and tell me how long that median is. Right? This is how I start to create the question that you guys are working on. Any questions? Okay with that? Okay, let's keep going. Show that DC bisects BC. What are we gonna do? So it wants to know that D actually bisects BC. What if BC wasn't long enough? Hmm?
That word.
Which word? Bisects, yeah. So it's like, bisects means like it's a cross. Like you're trying to show whether or not it crosses. Okay. What if I found, like if I said I need to show that the lengths of BD and DC are the same, right? If that's the case, then it better intersect at that point. Does that make sense or no? Let me reword that. If point D actually truly intersects there, okay, then I should be able to show that this length here is equal to this length because it went through the midpoint. So it better have broken that line in half. So to check, you better make sure that this length is equal to this length. Is that okay? All I'm doing is ask you to like think outside the box in a way that like you're proving some of the things that we've talked about at the top of this page. Using skills that you already know how to do. Right? You know how to solve for the length of line segments. So what I'm asking you to do is find the length of BD and DC. Show that they're equal. I'll write that here. Yeah. So if I show that the length of BD is equal to DC, right, then I know it actually intersects it at the midpoint, because the line AC, or the line segment AD, sorry, cuts that other one in half. So those two, if it cuts it in half, you better have two equal pieces on either side, right? Does that make sense? So if I go your distance equation of BD, let's see what that length is. So we're going to go to the square root of x2 plus x1 squared. Sorry. And we're going to add that to y2 minus y1.
Are you looking for D again?
Yeah, the length of, right? If 5,1 is truly the midpoint, then I better get two equal pieces here, is basically what's going to happen, right? So we're going to use point D, because that's what we just solved for. Right? We're going to plug in the points. B is going to be, we could say it's -6 minus -5 squared plus y2 is going to be -8 minus -1 square rooted. Okay, so the distance of BD be -1 squared plus okay, we're probably going to finish this question. We'll have to finish this later. Okay, I just want you guys to keep track of, like, all we're doing here is trying to prove the things that we said at the top to be true. Okay, so those definitions. So let's check the other half now, from D to C. Let's check the length of that. So the distance of DC is equal to, where are we? -4 minus -5 squared plus -6 minus -1 squared. That's all square rooted, right? So what are we going to get? -4 minus -5 should be 1 squared plus 6 minus -1 should be 7 squared. So I get the root of 1 plus 49, which is equal to root 50. Because those two things are equal on either side, I found two lengths, they're both equal. That means that the point D that we found was truly the midpoint, because it gave you two equal pieces on either side. We proved that. Okay? I think as a general rule for you guys, like we tell you guys all sorts of like different equations and things. Analytic geometry kind of breaks down what we give you into like actual proofs. Like this is why it is what it is. We told you a median went from one vertex to the midpoint of another line segment. So if you break a line segment in half, you better get two equal pieces. You can show that they're two equal pieces by finding the length of each piece. Yes, Ryan?
Did you just like make sure that the two lines are equal?
That proves that it's a midpoint, right? Okay? There's lots here. Not easy stuff either. Okay? We'll continue this in last period today. Okay?
This is our last lesson.
This is our last lesson. It's a good one.
Ooh.